What if I told you that climate change isn't really about temperature at all? And that the warming we hear so much about is just a symptom of something much bigger. It is a common thought that climate change equals to warming. While that is partly true, it is also misleading. Warming is not the root cause, it is just one of the visible outcomes of a deeper, much complex problem. Today, I'm going to explain why climate change is actually an energy imbalance issue, not just a temperature problem. And once we view it through this lens, all those extreme weather events around us, like drought to flooding to hurricane, start to make much more sense. Hello everyone, I am Professor Akinsanola, a climate scientist. I study how climate extreme, land-atmosphere interaction, and their impact shape our world. On this channel, we dig into the science of climate change, explaining it through physics, mathematics, and data-driven research. We do know that the Earth operates like an energy system, so to keep things stable, energy must come in and go out in a balanced way. So energy from the sun enters as a shortwave radiation, while the energy leaves as a long-wave infrared radiation. So for a stable climate, the amount of energy entering must balance the amount leaving. And this state is called equilibrium. But climate change happens when this balance is disrupted. For instance, when we increase greenhouse gases through increasing human activity, gases like carbon dioxide, methane, we're not adding more energy to the Earth. Instead, we're thickening the atmosphere, trapping heat that would normally escape. So imagine trying to heat a house by closing all the windows. You are not necessarily adding more heat, you are just making it harder for the existing heat to leave. So this trapped heat creates a net positive radiative imbalance at the top of the atmosphere. So as I said, climate change isn't just about a rise in surface temperature. Temperature is only one way the Earth responds to energy changes. So when excess energy builds up, it has to go somewhere. And it redistributes itself in several ways. For example, a large portion of this extra energy goes into melting ice, evaporating water, but this doesn't necessarily raise the air temperature as much. Instead, this energy goes into breaking molecule bonds. So while the ice melts, the surrounding air doesn't warm up as much. Also, a significant chunk of this excess energy fuels atmospheric circulation, for example, the movement of wind, leading to stronger wind in some regions, more intense storms, and also a more powerful hydrological cycle. So it is important to note that these changes are not homogeneous, they vary from region to region. Also, a large portion of this extra energy goes into heating the ocean. We do know that our oceans are excellent at absorbing heat because water has a high specific heat capacity. So which implies that it can absorb a lot of energy without rapidly increasing its temperature. So in fact, studies have shown that the ocean are absorbing about 90% of the extra heat we've been talking about. And that is why we see ocean temperature rising even if land temperature doesn't increase. So surface air temperature only represents about 2% of where all the excess energy goes. So when we talk about 2-degree rise, remember that temperature is just the tip of the iceberg. The real story is about energy imbalance, which affects the entire system in a more complex way. So why does this energy imbalance matter? So when we say that the world has warmed by 2 degrees Celsius, it sounds small, right? But consider this. The extra energy trapped in the system doesn't just increase the temperature, it amplifies the extreme weather. According to the physical law, Clausius-Clapeyron relationship, as the atmosphere warms, its capacity to hold water vapor increases by about 7% for every 1 degree Celsius rise. So that means more water vapor in the atmosphere, fueling stronger storm and heavier rainfall. So when it rains today, it doesn't just rain, it releases a huge amount of energy. And that is why we're seeing more intense weather events like flash floods, drought, heat wave, intense hurricane activities. So the Earth is trying to balance out the energy buildup in rapid and often more violent ways. So think of it like this. Surface temperature is like looking at the speedometer of a car, and this can only tell you how fast you're going. But it doesn't tell you how hard the engine is working or how much the pressure is in the tire. So if we only focus on temperature, we are missing the full picture. On this channel, we focus on understanding the engine of the climate system. We study how the energy flows, how the land and atmosphere interact, and how the Earth's energy balance is shifting. I strongly believe this will give us a deeper understanding of what is really going on. So next time you hear someone talking about climate change being just about warming, remember, it is really an energy imbalance problem. So the temperature increase is just a sign of a bigger shift and energy redistribution that is changing weather pattern in the ways we have never seen before. So I believe strongly that understanding this deeper physics is key to solving the problem. So if you want to dive deeper into the science of climate change and learn more about how the Earth system works, make sure you hit the subscribe button. So let's keep this conversation going and explore this critical issue together. Thanks for watching, and I will see you in the next video.